Hi, Calc 2 friends. We just have a couple sections to go over in 8.2. We're just going to go over the basics. I'll leave the details to the PowerPoint presentations. 8.1 is arc length. So what do we mean by that? Well, let f of x be a continuous curve. Let's just say over A to B, however we really want to go. So from here to here. Right? What we're looking for is to find the length of the actual curve. So like if we were to take a piece of string and place it on this curve and lift it up and stretch it out, how long would that be? Well, if f is a continuous function over an interval, then the length of the curve can be found by, we integrate from A to B. It's going to be 1 plus the derivative of f squared dx. Then the derivation is quite interesting. What it does is it breaks it down into little pieces, and then it looks at the lengths of all these little lines. And then, as always, we take the width of this and we let the width go to 0, which in turn turns into an integral. So that's how we find the length of a curve over an interval. So let's practice this. Let's find the length of the curve x to the 3/2 over the interval 0 to 4. So we have f of x equals x to the 3/2. And the derivative of f would be 3/2 x to the 1/2. And then we have to square the derivative. So that would be 9/4 x. And then we're going to look back at this template. So the length of the curve is going to be from 0 to 4, the square root of 1 plus 9/4 x dx. So what we're looking for here is the graph of y equals x to the 3/2 from 0 to 4. And if we were to stretch out this little sort of semi-parabolic shape, how long would that line be? Well, you can use u substitution here. When you do the work in between, you get 8/27. 1 plus 9/4 x to the 3/2. And we evaluate that from 0 to 4. And we get, not very pretty, 8/27. I think we get, that would be 10 because we put 4 in there. We get 1 plus 9, 10 to the 3/2 minus 8/27. We can't simplify that any further. That's an exact answer. But if we want to approximate it, the length of that line is about 9.1 units. So just be careful in WebAssign or in your directions. If it asks for an exact answer, this is what we want to see. If it asks you to approximate, then you're allowed to pick up your calculator and use it. All right, isn't that kind of cool? All right, let's try one more. Let's find the length of the curve. F of x equals the natural log of the secant over the interval 0, 4. So in order to find the length of the curve, we take the function and we take its derivative. So the derivative of the natural log of anything is 1 over that of anything times the derivative of what's inside, and the derivative of the secant is the secant tangent, right? Which just simplifies down. The secants cancel, it's just tangent. So the derivative squared would just be tangent squared. So therefore, the length would be from 0 to pi over 4. And we're going to integrate the square root of 1 plus the derivative squared. Okay, so everything we've learned in previous chapters applies. Well, 1 plus the tangent squared is just the secant squared. So we're really just evaluating 0 pi over 4, square root of secant squared. Right, but the square root of secant squared over a positive interval is just the secant. 0 to pi over 4, secant x dx. Now back in the let me think what section we did this earlier. We did integrate this. I showed you there was that trick. You multiply by the secant plus the tangent over the secant plus the tangent. You have it in your integration handout also. You can assume, because we've done it, we've already gone through the process, there's no need to reinvent the wheel. The antiderivative of the secant is the natural log of the secant plus the tangent. And we're going to evaluate that from 0 to pi over 4. Now again, always exact answers unless otherwise stated. So now here's where your trig knowledge comes into place. So it's the natural log of the secant of pi over 4 plus the tangent of pi over 4 minus the natural log of the secant of 0 plus the tangent of 0. All right, well, the secant of pi over 4 is the square root of 2. Tangent of pi over 4 is 1. The secant of 0 is 1, and the tangent of 0 is 0. So we get the natural log of, and I can eliminate the absolute values because the square root of 2 plus 1 is a positive number. If it was not positive, I'd have to keep the absolute values, minus the natural log of 1, but the natural log of 1 is 0. So the exact answer is the natural log of the square root of 2 plus 1. Right. All right, well, as in previous sections, we don't always just look at y as a function of x. What if x is a function of y? So let's find the length of the curve g of y equals 2/3 y minus 1 to the 3/2 between 1 and 4. Well, we need a template for the turn of this, integrating along the y-axis instead of integrating along the x-axis. So it's not much different. The length is just going to be, well, we go from lower to upper, so we say from C to D, then it's going to be the square root of 1 plus g prime of y squared. We integrate with respect to y. Okay. So let's take this, we're going to go down here, and we're going to get, we have g of y equals 2/3 y minus 1 to the 3/2. So the derivative of g, bring the 3/2 out front nicely, that cancels with the 2/3. We get y minus 1, 3/2 minus 1 is 1/2. The derivative of what's inside is just 1. So g prime of y squared is just y minus 1 to the 1/2. We can see what's going to happen. It's just y minus 1. So now we're going to integrate. The length is just from 1 to 4, the square root of 1 plus y minus 1 dy. And look how nice that turned out. 1 to 4 y dy. The antiderivative of y is y to the 1/2, 3/2, whoops, no, 2/3 y to the 3/2. We evaluate that from 1 to 4, and you do the work. 2/3 4 to the 3/2 minus 2/3 1 to the 3/2, and you should get 14/3. All right, so there are the mechanics for you. Again, for the details on the proof, I'm going to let you read that in the PowerPoint, and I'll see you in 8.2.